space experts have viewed a weird structure close to Andromeda that is nearly as extensive as the actual world. This disclosure bewildered cosmologists in light of the fact that the world's best telescopes had never seen this colossal, ring-shaped something before. The find was made by novice stargazers using a relatively modest telescope. Now, researchers are thinking about exactly what the construction is and considering what else they could have ignored in the universe. The Andromeda Galaxy is no longer a specific feature for cosmologists. Our adjoining system, also known as M31, is considered by specialists to be very well known and has been captured and investigated thousands of times. With its grand winding design extending over 220,000 light-years, Andromeda is 2 times the size of our own universe and is home to around 1 trillion stars. On a starry evening, it tends to be viewed as a sensitive shining spot overhead, a fascinating sight that also inspired 3 amateur space experts from the US to take some extremely special photos of the system to make our adjoining galaxy shine in a unique light. The 3 used different color channels, which uncovered a construction that had gotten away from the best cosmologists on Earth. The construction had been straightforwardly in view this time, but its quirks made it challenging to see the aspects of the arrangement alone. The strange design is nearly as huge as the Andromeda cosmic system itself. This truly makes us can't help thinking about how a design of this size might have been ignored for such a long time. The answer to this inquiry is basically that the newly found structure comprises only of the best gas, like the fine rings around Uranus and Jupiter, which could only be seen with exceptionally advanced technologies. The same applies to the unusual construction that half-wraps the Andromeda Galaxy. The 3 pioneers used a special channel that only lets the light of doubly ionized oxygen through. Through this channel, the gas cloud delivered a strange blue-green glow that is ordinarily imperceptible to the human eye, but was amazingly featured by the technique used. After the amateur space experts reported their discovery, it was confirmed by professional researchers using data from several telescopes in France, California, and New Mexico. Nobody understands what this design truly is. Curiously, scientists have, so far, been unable to make sense of why this colossal structure has stayed undetected until now. Large informational indexes from various parts of the electromagnetic spectrum, for example, X-rays, ultraviolet, and infrared light, showed no proof of this gas cloud. The fact that it makes it moreover precluded a mistake in the picture processing or stray light. The meaning of this revelation is extensive. Some cosmologists suspect that the construction could be a sign of the starting communication of the cosmic coronas of Andromeda and the Milky Way, since the 2 systems will crash in around 5 billion years. But the exact origin and nature of this structure remain a mystery to be solved. The design could be an early indication of the looming consolidation of Andromeda and the Milky Way, since the cosmic coronas, the colossal, almost imperceptible shells of gas, residue, and dark matter surrounding the galaxies, may already be connecting. Both galaxies are moving towards one another at a speed of around 110 kilometers per second and will crash in about 5 billion years. When their coronas begin to overlap, processes like gravitational impacts or shock waves could emerge, altering the gas distribution and causing emissions like those from the found structure. The tremendous gas cloud that this construction represents could be the result of such interactions in which gas between the galaxies is packed or heated. Besides, the cloud might have been created by cosmic winds or flows that were increased by the approach. This discovery, therefore, provides valuable insights into how the early stages of galaxy mergers happen. All facts considered, have researchers made a mistake? The explanation that past examinations have found no evidence of this design being a curio means that scientists have ruled out the possibility that the noticed design was caused by technical errors, picture processing issues, or stray light. This was confirmed by comparison with data from various frequency ranges. What are frequency measurements in cosmology? Divine objects are considered through their electromagnetic radiation. This radiation encompasses different frequencies, ranging from short-frequency X-rays and ultraviolet, UV, light to long-frequency infrared, IR, or radio waves. Since each physical phenomenon, for instance, gas, dust, stars, or black holes, emit specific radiation that depends on the frequency, cosmologists can obtain a comprehensive picture of an object by using multi-frequency observations. What are these measurements good for? Multi-frequency informational indexes are essential for a complete understanding of celestial objects and processes. X-rays are frequently transmitted by very hot gases, for example, shock waves, or around black holes. They show dynamic processes in galaxies. UV light reveals youthful, hot stars and areas of intense star formation. Infrared light captures cooler material like dust, atomic clouds, or faint galaxies that are obscured optically. What do these measurements show in terms of the design for the found structure close to the Andromeda Galaxy? Past investigations in all of these frequency ranges have not found any emissions, which makes it even more strange. Gas clouds would normally produce infrared or UV radiation, for instance, but the fact that it's only visible through the blue emission of ionized oxygen suggests that this gas cloud represents a very special physical anomaly, either extremely thin or curiously shaped by processes that only occur in specific periods of cosmic interactions. The strange formation close to the Andromeda Galaxy has left researchers with several questions. Here are 3 potential explanations for its origin, along with an additional theory that goes beyond the current structure. Hypothesis 1. A remnant from prior cosmic interactions. The design could be a leftover from a previous encounter between Andromeda and a smaller galaxy. In such cases, gas and dust streams are often pulled out of the galaxies during gravitational interactions, forming enormous gas clouds or streams. These relics often have a unique chemical composition and could correspond to the specific oxygen emissions from the formation. Since Andromeda has a history of absorbing dwarf galaxies, this structure could be a not yet fully integrated remnant. Hypothesis 2. A previously unseen grandiose cloud structure. Another explanation could be that the formation is a giant emission cloud that has been ionized by a previously unknown source. Such clouds often form when radiation from hot stars or supernovae ionizes the surrounding gas, causing specific emissions. The fact that the formation is so large and consists of ionized oxygen could indicate that it was affected by an incredibly massive event, such as an old star-forming region or even an active galactic core. Hypothesis 3. An intergalactic gas cloud. It's possible that the formation doesn't directly belong to the Andromeda Galaxy at all but represents a massive intergalactic gas cloud that has been gravitationally pulled toward Andromeda. Such clouds could be remnants from the early period of the universe when galaxies and galaxy clusters formed. Its isolated position and composition could suggest that cosmic flows have drawn it into the region of Andromeda. Hypothesis 4. A sign of dark matter or fascinating processes. One intriguing hypothesis is that the formation is an indirect sign of interaction with dark matter or other unusual physical processes. Dark matter might have affected or compressed the gas in the formation, causing it to ionize. This idea could explain why the object was so difficult to detect and shows no signs in other frequency ranges. The discovery of the mysterious structure near the Andromeda Galaxy is a striking example of how much of the universe remains unseen, even in well-studied regions like our vast neighborhood. The fact that this immense formation has been overlooked despite decades of observations by the best telescopes raises crucial questions about how much of the true design and arrangement of the universe has remained hidden until now. The significance of this discovery is that it may show that the astronomical gas web of the universe, consisting of massive gas clouds, fibers, and coronas, is still largely unexplored. Neglected anyway, these vaporous structures assume an essential part in the development and advancement of galaxies. They supply galaxies with new gas for star development and impact their advancement through gravitational and streaming impacts. The fact that such a development has only now been found suggests that many other similar structures, maybe much larger or more complex ones, might exist that are not yet visible through traditional observational techniques. This could mean that there are gaps in our understanding of cosmic interactions, star development, and large-scale evolution. What else could hide unseen in intergalactic gas mists? A large number of the giant gas structures that form the filamentary organization of the universe have not yet been mapped. These fibers connect galaxy clusters and could contain the missing baryonic material that cosmologists are searching for in the mass equilibrium of the universe. Stowed away star development gas mists, that are imperceptible in certain frequency ranges, could hold unseen sites of extraordinary star development, dark matter, and gravitational lensing. The discovery also shows that dark matter structures, which dominate the universe, could influence gas mists and their elements, revealing undetectable associations. How could researchers find such structures? By growing multi-frequency techniques, the utilization of specific channels, as used in this discovery, is vital. Future telescopes could specifically look at frequency ranges that have been gathered so far, including amateur space science. The discovery by amateur space experts shows that broad support and inventive methodologies can open up new possibilities. New advances in calculations, as well as progress in artificial intelligence and image processing, could assist in identifying fine structures in existing galactic data that have been ignored so far. The implications for research are significant. The discovery clarifies that our models of the universe must remain dynamic. It shows that crucial pieces of the puzzle for how we understand galaxy development, cosmic structure, and the organization of matter in the universe are still absent. Each new revelation could significantly change our perspective on the universe.